All right. What's going on? I feel like I haven't made a video for you guys in a minute. So I'm diving back in here Sunday morning, 60 degrees outside. I'm going to try to knock out some lesson planning and then get outside before the Titans game later. But the focus of this video is to introduce to you two more identities that we'll use later this week. It's to give you like the top 5 what I call tools to use when you're solving a proof. And then we're just going to do a couple like medium level / hard level proofs just to try to get better. So let's start with the new identities, I think. So far we've learned 8. I'm really hoping that you know these 8. Let me erase this. I'm really hoping that you feel really comfortable with what are called the reciprocal identities. And I'm really hoping that you're getting more comfortable with the Pythagorean identities and all of their many variations. Okay, I'm going to go back to red. No, I'm going to use green. Let's do a different color for each set. This next identities, number 9 and 10, there's only 2 of them. These are called the double angle identities, and you'll see why they get their name here shortly. So number 9 is sine of 2 theta. Did I use x or theta? No, I've been using theta on these. Okay, I'll stay consistent. So sine of theta is up top. This is sine of 2 theta. It's a double angle. The angle is doubled. And sine of 2 theta is actually the exact same thing as 2 sine cosine. Remember, these can be x's or thetas. It's just a variable is all it is. So if you want to write yours in as x's, that's totally fine. 2 sine of x equals 2 sine cosine. It's called the double angle identity. You look out for that 2 being in front of the angle spot. And then number 10 is the cosine of 2 theta. It's the double angle for cosine. There's actually 3 variations of this. The main variation is cosine squared minus sine squared. That's the main variation. But then what we're going to do is to get the other 2 variations, it's just found by using these. Remember, sine squared is the same thing as 1 minus cosine, and cosine squared is the same thing as 1 minus sine. Like all of these identities just mean like true statements, things that are true. We could prove all of these and go, you could Google like, why are the Pythagorean identities true? And then you'll see someone proving them. We just don't really have the time to prove them. And it's a little off the beaten path. I just want you to know that these are true and that we will use them. So what would we get if we switched out a cosine squared? I'll do this off to the side. If we switched out a cosine squared right there with a 1 minus sine squared, and we still had the minus sine squared, that would combine to 1 minus 2 sine squared. That's the second variation. So it equals this, or it equals 1 minus 2 sine squared. And then the other variation would be, I'm just going to give it to you to save time, but it's just if you switched in a 1 minus cosine squared in for the sine squared, it would be 2 cosine squared minus 1. Those are the 3 variations for the cosine of 2 theta, and they each will come in handy at certain points, especially when we move into a hard level proof later in the week. That's going to pop up. Okay, so those are the 2 new identities. You use those the exact same way. Like, let me try to just make one up. Like, you might see this. You might see 1/2 secant theta times sine of 2 theta equals sine. Like, I just made that up. And let's see how you use this. The left side is more complicated. I'm going to switch I'm going to switch this sine of 2 theta out for a 2 sine cosine. We just learned that. I'm going to bring down my secant. I'm going to bring down my 1/2. Okay? Remember, these are being multiplied. And then at this point, what do you know? 2 and 1/2 cancels. Secant and cosine cancel. But I need to probably prove that. Secant is 1 over cosine. And then we still have our sine. And we still have our cosine. So once I prove that, I can go whoosh, whoosh, and I'm just left with sine equals sine. I proved it. So just wanted you to see, it's just a new identity is all. Right there. 2 sine cosine switches in for sine of 2 theta. Okay, these are called the double angle identities, and we'll use them. Okay? So at this point, we are getting into where it's all easy, medium level. Hards are coming later. And I want to give you, and I would put this on your sheet somewhere. Don't put that example on your sheet, but I'm going to give you the 5 like main things that you look for. We'll just call it our proof toolbox. And I'm just going to take literally 2 minutes to do this so that we can spend the last 5 minutes just solving proofs. So proof toolbox. Number 1, you always look to factor if possible. And remember, we have four factoring methods. We went over this in class, so I'm not going to go over it now. But GCF, difference of squares, trial and error grouping. Okay. Second, look to substitute in identities. See if you can make some identities. Identities, I misspelled that, whatever. Substitute identities in there. Number 3, look to do a least common denominator to add 2 fractions. Okay. Number 4, you change everything into sines and cosines. What do I mean by that? I mean, if there's any identity that can be written, like look, tangent can be written in terms of sine and cosine. Cotangent can be written in terms of sines and cosines. Cosecant can, secant can. Basically, any identity that you can just make a switch to write it in the form of sine and cosine, you're probably going to be able to cancel something out, which is what you want. What was the last one? So you look to factor, you look to substitute, maybe least common denominator, change the sine and cosine. I think the last one is just sometimes you FOIL or distribute. Like sometimes you multiply. Doesn't happen all the time, but sometimes you do. So let's go try some. I have so many different sheets, and so we'll practice a ton. I'm just going to pull up a random sheet that has some proofs on it. We'll look at them. Okay, these are specifically, we can do some factoring on this one. So let me do, let's do this one. You're on a quiz. You see that proof right there. Secant squared, tangent squared, plus secant squared equals 1. Equals 1, so it's all got to cancel out at some point into 1, which is kind of interesting. So we draw our line. We know that we're going to do something on this side. It's way more complicated. You always need to factor first. So don't even start switching these. Like, don't change this to 1 over cosine just yet. We need to see if we can factor. We need to factor first, and we can. This term and this term, they share a GCF. They share a secant squared, so we need to pull out that secant squared, which would leave behind a tangent squared plus 1. Let me pause there. I just factored out a GCF. It's like reverse distributive property, right? If you don't believe me, remultiply that, and you'll be right back at the beginning. Okay, but we factored that out. Now, tangent squared plus 1. That sounds familiar, and I'm hoping at this point when you see tangent squared plus 1, I'm hoping that your brain goes straight to here. Identity number 7, where it tells us that a tangent squared plus 1 is the exact same thing as a secant squared. Okay, so I am going to And that is hilarious that I chose this example because this just hit me from last year when I did this problem. But there's a typo in here because look, secant squared times secant squared does not equal 1. And so I remember every year there's this darn typo. And so I need to switch out the tangent for a cotangent. Because if we, so sorry, you can redo this problem with the cotangent there and it will work. You still factor it, but this is a cotangent, which would make this cotangent squared plus 1 is cosecant. You know what? I just butchered that too. Because this is secant, we need this to end up being a cosine. And so that the typo is actually, instead of a tangent, put a cosine there. Sorry. Wait. You're seeing me do like 5 steps ahead and try to fix this problem on the fly, and it's not working. Tangent squared plus 1 is secant squared. So then we need that to be a cosine. That's what it is. Instead of these being secants and secants, these need to be cosines, both of them. My bad, because look what's going to happen. Instead of factoring out a secant, they share a cosine, so we pull out a cosine. And tangent squared plus 1 turns into secant squared. That's identity number 7, right? We just said. So we pulled out a GCF, and then we used identity 7. And what is cosine times secant? Cosine times secant is 1. My bad. Forgot about number 52. Of course, the one I picked is the one with the typo that I need to change. Okay, let's do another one. That one had factoring in it. Let's do like this one. I draw my line. You see, boom, factor. Factor that right there. It's going to jump out at you, trial and error, so we need to do 2 sets of parentheses. Sine to the 4th gets broken down into sine squared times sine squared. I'm really hoping that we get comfortable at factoring this. And remember, I said if you ever see a 4th power, you're probably going to factor. So sine to the 4th gets broken down to sine and sine. This 1 right here gets broken down into 1 and 1. We need a negative 2, so it's negative and negative. So, where do we go from here? We need it to equal cosine to the 4th. Sine squared x minus 1. I go back to my identity sheet. And I see that a sine squared can get switched out for a 1 minus cosine. Let's try that. Let's put a 1 minus cosine into our sine squared. So this gets turned into a 1 minus cosine squared minus 1. And this gets turned into a 1 minus cosine squared. And then bring down this minus 1. And let's see what happens. See if I can cancel now. 1 minus 1. Yeah, those 1's cancel. 1 minus 1. Those are gone. And so we're literally just left with a negative cosine squared times a negative cosine squared, which is positive cosine to the 4th, which is what we were trying to get. So I'm running out of time, so I got to wrap it up here, but I definitely encourage you to just rewind and watch what I did again. Okay, it was factoring, and then it was identities, number 6, one of the variations. Okay, so remember your tools. You always look to factor first, if you can. Right here. Screenshot that on your phone. If you can factor first, you factor. Then you go to identities. Then you look to use some algebra after that. Okay, tell me 2 things that you learned, 1 thing that you still have a question about, and we'll go from there.